Hello everyone, in this video we're going to learn how to solve a system of equations using inverse matrices. Alright, first we need to learn how to write a system of equations as a matrix equation. Now if you want to write a system of equations as a matrix equation, AX equals B, you need to use a coefficient matrix, variable matrix, and constant matrix. So if you look at this one right here, 2x plus 3y equals 1. 5x minus 2y equals 13. Alright, so coefficient matrix A is the coefficient of this one right here. Right? So you have 2, 3, 5, and negative 2. Make sure you include negative side right here. Now, the variable matrix is x and y. Look, the top and bottom, they're both the same, so you just write one only, right? So you're gonna write one column, but two rows, right? And the last one, the constant matrix B, which is the constant on the right-hand side right here, 11 and 13, right? Now, in order to solve a system of equations, we're gonna use inverse matrices, right? If matrix A has an inverse, you can use it to solve the matrix equation AX equals B by multiplying each side of the equation by A inverse to 5x. Alright, so this one is original matrix equation. I'm going to multiply both sides by A inverse, right? So this guy times this guy turns out to be identity matrix. Identity matrix multiplied by the matrix is going to be dash matrix. Right? The right hand side is going to be A inverse times B. Right? Now, let's move on to example number 1. We're going to write a system as a matrix equation. So, in order to write a system as a matrix equation, we need to use coefficient matrix, variable matrix, and constant matrix, right? Alright, so coefficient matrix A is 4, 7, negative 5, and 3. The variable matrix is x and y right here. And the constant matrix B is going to be the constant on the right hand side right here, 6, 1, right? So we're going to put them together. It's going to be. Now for question B, we need to rearrange the variables, right? So the first equation is good, right? Now the second equation, we don't have A, so we're going to add 0A plus 7B plus 2C equals 8, right? And the last equation, we have 5A, right? But we don't have B, right? So we're going to add 0B, right? And we're going to subtract 3C both sides, right? And it's going to be 1, right? So similarly, we need to have the coefficient matrix, variable matrix, and constant matrix. Alright, so coefficient matrix A is 3, 5, negative 12, 0, 7, 2, 5, 0, and negative 3. And the variable matrix is going to be A, B, C, right? And the last one, constant matrix, 6, 8, 1. Now we're going to put them together, so we have. Now let's move on to example number 2. We're going to use an inverse matrix to solve the linear system. Question A. Negative 4x plus 7y equals negative 9. 2x minus y equals 2. So what we need to do is to find AX equals B, like what we did before, right? So coefficient matrix is negative 4, 7, 2, negative 1, right? And variable matrix S, which is x and y, right, equals the constant matrix B, which is this guy, right? What we need to do is to find the inverse of this matrix A right here, right? So remember, inverse of the matrix A is 1 over determinant of the matrix A times. We're gonna swap the position of this guy, right? So you have negative 1, negative 4, and we're gonna change the sign of 2, 7, right? So – determinant of the matrix A is -4 times -1 should be 4. Subtract 2 times 7 is going to be 14. So it could be -10. So I have -1/10, right? Times -1, -2, -7, -4, right? Now I'm going to take each of these elements right here, divide by -10. So I'm going to end up with 1/10, 7/10, 1/5, and 2/5, right? Now I'm going to multiply both sides of this guy by A inverse, right? So does that mean this guy times this guy becomes identity, right? So it becomes S and Y, right? Equals this guy multiplied by this guy, right? Now this guy 2 by 2 matrix, this guy 2 by 1 matrix. So your answer must be 2 by 1 matrix because this guy the same, right? Alright, so 1/10 times -9 is going to be -9/10 plus 7/10 times 2 is going to be 14/10, right? Now we're going to add this guy up, so it could be 5/10, which is 1/2, right? So we have 1/2 here. And the second one, 1/5 times -9 is going to be -9/5, right? 2/5 times 2 is going to be 4/5, right? We're going to add this guy up. It's going to be -5/5 and it's going to be -1, right? So finally, S equals 1/2, right? Y equals -1 is the answer, right? Now A is 3, 1, and -2. -2, 2, and 3. And 5, -1, -3. And variable matrix is X, Y, Z equals constant matrix is 3, -14, and 25. So we need to find the inverse matrix of the matrix A right here. Now, if you want to refresh how to find the inverse of the 3 by 3 matrix using two methods, you're going to check out the link in the description below. Now I just give you the answer. I'm going to let this one for you to practice. Now we're going to multiply both sides by A inverse, right? So the left hand side becomes X, Y, Z, right? Because these two guys right here becomes identity, right? So the right hand side becomes A inverse. I'm going to copy this one over here. Multiply by 3, -14, and 25. Now this one is 3 by 3 matrix. This one 3 by 1 matrix. So the answer must be 3 by 1 matrix, right? Because this guy the same. -3/16 times 3 plus 5/16 times -14 plus 7/16 times 25. The second one, 9/16 times 3, 1/16 times -14, and -5/16 times 25. And the last one, -1/2 times 3, plus 1/2 times -14, plus 1/2 times 25. Now, if you simplify this one, it's going to be 6, -7, and 4. And it's your time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals, they take us higher. The night's young and it's just begun as she puts her hand in mine.